All right, so this is our first section on factoring trinomials, and these ones are a lot nicer than the next section that we see. The next section will be dealing with trinomials that we'll have to use grouping for, like we saw in 6.1. These ones are nicer because we can kind of skip all of that, and we're going to go straight from the polynomial we start with to our answer in just one step. So let's again take a look at factors. So if you remember, if we have something like x minus 3 times x plus 1, we can go ahead and multiply all of this out. If we were to FOIL it out, combine like terms, I'm not going to show all the work, but we would get x squared minus 2x minus 3. So now what we're going to be doing is we're going to be going from something like this back to the groups that multiply to give us that. So this is what we're going to be doing when we factor these. And so what we're going to be looking at in this section of trinomials is factoring stuff that has the form x squared plus bx plus c. So the important thing here is that the leading coefficient, or the number in the front of the x squared, write this out, leading coefficient is equal to 1. That's the big thing here. In order to do this kind of shortcut, you have to have just an x squared. You can't have another number in front of it. And so let's go ahead and look at an example before we run through just a bunch more examples. Let's say we're told to factor x squared plus 5x plus 6. So the trick with these is, if you notice up in this example up here, our last terms, negative 3 and 1, multiply to give us this last number here. So we always want to find two numbers that multiply to our last digit, so positive 6, and they have to add up to the middle number, which is 5. This is going to come back into play when we're looking at our next section of trinomials. They're going to be a little bit different, but we're still going to be finding two numbers that multiply to something and add to something else. The reason why they have to add to 5 is because our outside, so this 1 and the negative 3x, have to add up to, or add up to this negative 2. Negative 3 plus 1 is negative 2. Same thing here, they're going to have to add up to 5. So with numbers like this, it's not as hard to kind of think about what they are and then factor. If they're a little bit bigger, what I'll do is write out the factors of 6, because we know they have to multiply to 6, so I'll write out 1 times 6, 2 times 3, and we want the pair that adds up to 5, so it has to be these guys. So let's go ahead and factor this. One other thing really fast that I do want to show you is the big X method. This is something you might have seen before. You might not have. If you don't want to use this, you don't have to. It's just kind of a way of organizing your numbers. And so you can always write it out like this with multiply to and add to. Think about it in your head. I think it's always nicer to kind of write stuff down and get it down on paper so you can see your work. If we do it like this, the multiply 2 is going to go up top, so I'll put a 6 up here. Add 2 is going to go on the bottom. And then whatever two numbers you're looking for can go on the sides, so 2 and 3, and I'll circle those. You don't have to fill this in though. If you want to just organize it like that, you can. If you don't want to use the big X method, you don't have to. That's completely fine. But what we're going to do now in order to factor this is we're going to set up our two parentheses. The first terms, depending on what you're looking at, most of the time will be x's, because x times x is x squared, so you're going to get that from this first term. And then the last two terms are going to be the two numbers you get. They're both positive, so plus 2, plus 3. And that's it. Our check, as usual, is FOILing. So if you wanted to check this, you multiply it all out, make sure you get this guy. But that's all we have to do for these. Find our two numbers, put them in the parentheses. let's try some more examples. A lot of them are going to be really nice like that. A couple of them we will have to factor out the greatest common factor first, like we'll see at the very end. But for the most part, these ones are generally really nice. So let's go ahead and try x squared plus 12x plus 20. I'm going to use the big X. So we need to multiply to our last number. So we're going to multiply to 20, add to 12. So remember, this is multiply to, this is add to. See if you can think of two numbers that multiply to 20, add to 12. If you get stuck, you can list out the factors. So 20, 1 times 20, then go up from 1, 2 times 10, 3 doesn't go into it. And you can always stop when you get to the two numbers. So if you notice 2 and 10 add up to 12, those are our two numbers. And so now we can go straight to our answer. So it's again an x squared, so it's going to be x plus 2, and then x plus 10. Number 2, let's try one with some negatives. Negatives are where they start to get a little more confusing. This one is t squared minus 12t plus 32. So we want to go ahead and again figure out what we're multiplying to, what we're adding to. We're going to multiply to 32. We're adding to negative 12. So keep the sign that is in front of the number. And so how do we multiply to a positive but add to a negative? Well, multiplying to a positive means we either have positive times positive or negative times a negative. The only way to add to a negative is to have two negative numbers. So I'm going to list out the factors of 32 again. 1 and 32, 2 and 16, 3 doesn't go into it, 4 goes into it 8 times. That's all of our factors. We know that they both have to be negative. So I'm going to make all of these negative. And then which pair adds up to negative 12? Negative 4 and negative 8. So now the only difference is when we factor this, we're going to have, for one thing, it's a t squared, so it's going to be t's in the front. And then they're both negative, so it's going to be t minus 4 and t minus 8. Negative is a minus, positive is a plus. Okay, this next one's pretty similar, so I would go ahead and try this one if you're feeling somewhat comfortable with these. Y squared minus 10y plus 24. So again, what are we multiplying to? 24. What are we adding to? Negative 10. So think of the signs first. Multiplying to a positive, adding to a negative, we need two negatives. So let's list out our factors. We've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. They all have to be negative. This part is not as important here. It'll be really helpful once we get to another case where we have a positive and a negative. But our two numbers here are negative 4 and negative 6. So our answer, again, check your variable. If you're getting mistakes or getting questions wrong on my math lab, sometimes it's as simple as we're using the wrong variable. This one's a y, so we want y minus 4 and y minus 6. And again, same thing with this. If you wanted to flip these around, that's also correct. So if you did y minus 6, y minus 4, as long as your y's are in the correct place and they're both negative numbers, you can flip around your factors because we're still just multiplying and multiplication is commutative. All right, let's try a few more of these. Let's go ahead and do, let's do z squared plus z minus 30. So this one's different for a couple of reasons. Let's set up our big X. We're multiplying to a negative 30. The only way to get a negative is to have a positive and a negative. And then we're adding up to our middle number, which in this case is 1. If you don't see a number, it's a 1. So let's go ahead and write out our factors of 30. We've got 1 and 30, 2 and 15, 3 and 10, 4 doesn't go into it, 5 goes into it 6 times, and we're back in the middle. So we know 1 has to be positive, 1 is negative. If you list them out like this, couple things to look for. Because they're positive and negative, their difference should be 1. So 5 and 6 have a difference of 1. We have to know which one is positive, which one's negative. Since we're adding to a positive 1, the larger number is positive and the smaller number is negative. So 6 and negative 5. If you're ever unsure about which one's negative, you can always play around with it. If I put the negative with the 6 instead, adding these together gives us a negative 1. So that means you just have to flip it around. If we added those together and we got something that wasn't even a 1, you would know that you have the wrong pair of numbers. Because let's say we had 3 and 10. This would give us a 7 or a negative 7. Either way, it's going to give us a 7 of some form. Changing the negative sign around changes the sign of the number. It's not going to change the number itself. Okay, now let's go ahead and factor this. We've got z plus 6 and z minus 5. All right, let's try some more. Number 5. Let's go ahead and do a squared minus 9a minus 22. So this is another one where we're dealing with a negative. If we look at this last number here, we're multiplying to negative 22, adding to negative 9. So I would go ahead and try this one by yourself first. Just remember you're multiplying to a negative, so you have a positive and a negative, adding to negative 9. So the difference between your two numbers has to be 9. If we go through the factors of 22, there aren't many. We have 1 and 22, 2 and 11. 2 and 11 have a difference of 9. I'm going to circle those. And now because we're adding to a negative, the larger number has to be negative. So 2 and negative 11. So we have a plus 2 times a minus 11. Okay, number 6. X squared plus 5x plus 8. So for this one, let's look at our big X first. We're multiplying to 8, adding up to 5, some nice positive numbers to deal with. The factors of 8, we've got 1 and 8, 2 and 4. 1 and 8 don't add up to 5, neither do 2 and 4. So since we don't have any numbers that multiply to 8 and add to 5, we're going to say that this one is, forgetting what they put on my math lab, either not factorable, that just means that we can't factor it, or what we call prime. So in my math lab, it'll say either one of these. I usually put prime. The way to remember this is think of prime numbers. So prime number like 3. The only thing you can do is break it down into 1 and 3. But they don't have any other factors that go into it. Same thing with these, we can't break it down. We could break it down into 1 times this whole thing, but that's not gonna do anything to help us. So they're prime in the sense that you can't break them down anymore, just like prime numbers. And so anytime you get that you can't multiply and add to the two numbers, it's going to be prime. Let's try another one. So this next one is a little trickier. This one we're given b squared minus 3ab minus 4a squared. All right, so anytime you have anything like this where it looks a little bit more complicated, there's more stuff going on, always check for GCFs first. And if we look at all three of our terms, we have a b in the first two terms, not in the last one. We have a's in the last two terms, but not in the first one. They don't have any numbers in common, so we can't actually factor out a GCF. But because it starts with just a b squared, there's no coefficient in front. We know that we're able to do this kind of factoring. So I'm going to do the same kind of thing. I'm going to set up our big X. Ignore all the extra variables for now and focus just on the numbers. So we're multiplying to -4, adding to -3. So we need a positive and a negative. We've got 1 and 4, 2 and 2. They have to have a difference of 3. That's going to be 1 and 4, and the 4 has to be negative. So now the only thing to be careful here when you factor is that the first terms are still b's. So we're going to have a b, leave space, and a b to get that b squared. We're going to have a positive 1, so I'm going to put +1, leave a space, -4, leave a space, because our last term here is an a squared. So we need an a and an a to get that a squared. So this one's tricky just because of that extra a there. And you might be thinking, well, that gets us an a squared, but what about this ab in the middle? Well, if you think about foiling this, b times b is b squared. B times -4a is -4ab. And the middle terms give us a +1ab. So it does give us what we have up here. Just looks a little bit weirder when you're factoring it out. All right, let's go ahead and try one more. This is one of the other ones you have to be careful with. -5y to the 5th minus 15y to the 4th plus 90y cubed. So again, anytime you have something that doesn't have a number or it has a number in the front, it's not like one of these that we've been factoring. And the exponents on the variables are pretty big. You want to have a y squared or a b squared, a squared, x squared. The first term should be squared. So if you notice for this one, we can factor out the GCF first. And you always want to do that if it's an option. It won't always be an option. But here, we can take out, now it starts with a negative, so take out a negative. It's going to make factoring it easier. And then we can take out a y cubed. So first term, -5 over -5 is 1. We're left with a y squared. -15 over -5 is +3. We're left with a single y. 90 divided by -5 is -18. And we're not left with any y's there. We're part of the way done with factoring. Now we want to go ahead and factor this trinomial. So 3 terms, we know we want to use big X. We're going to use the big X again in the next section. This is a reason why I really like using the big X. It just kind of, it can get you started on what to do if you kind of forget. So if you think 3 terms big X, it'll remind you that you need to multiply to something, add to something. I think it's just kind of a good reminder on what to do. Okay, so when we start factoring that trinomial, we don't care about this -5y cubed in the front for that part. We're going to leave that in the front, and then we'll have our 2 sets of parentheses there. We're going to multiply to negative 18, add up to 3. So we need a positive and a negative. 1 and 18, 2 and 9, 3 and 6. And so the ones with a difference of 3, 3 and 6, adding up to a positive, so the 3 has to be negative. And so now putting this back into the parentheses, we're going to have y minus 3 and y plus 6. So a big thing here, make sure you don't lose that GCF in the front. In order to get from our answer back to the original problem, you have to have this negative 5y cubed. Otherwise, it would only get you this y squared plus 3y minus 18. We don't just want that, we want this whole thing. All right, so the next time we'll take a look at some more trinomials, but we'll be factoring them by grouping because we're going to have numbers in front of that leading term. And then we'll look at some other kind of special factoring techniques. And then we'll be just about done with factoring. We'll look at kind of a general approach, so we're going to look at all of it put together.